So James O'Neill is a service and systems design lead with us here at FJORD in Dublin. His work focuses on the human experience of AI-enabled systems. James is interested in how we can design for positive outcomes in the midst of complexity. His work has covered domains as diverse as policing, digital marketing and drug discovery, so all over the client, different client projects and challenges. He also recently exhibited a piece of speculative design that he created with his colleague Frauke Hein at the EPIC conference. That piece is actually down the back of the room afterwards if you're curious. It's called Office Humour.
Hi, I am James. I want to talk to you a little bit about kind of picking up on what Jerry started about trust, but in particular, how can you start to design for trust in areas where you have it's kind of like a new field of like human AI collaboration. And one of the interesting things that we've been discovering in projects like that is that trust is like a really important piece of currency, interaction currency, when you're talking about who's taking responsibility for what tasks, when you're thinking about humans and AI working together. But first, I want to talk about chess. So, in 1997, a computer from IBM called Deep Blue defeated the reigning chess grandmaster Garry Kasparov over 6 games of chess, and all the world watched, and the result was kind of one of two ways. Some people were like very optimistic about the results, saying, yes, finally, technology can win at chess, think of all the amazing things we'll be able to do with technology in the coming years. And the other side was like, oh good God, technology can win at chess, we're all going to be redundant, all the computers will take over. But for our story, we're not really interested in what all these people thought. We're kind of interested in what Garry Kasparov thought. And Kasparov took a really interesting approach. Yes, he was disappointed that he lost to a computer, but he didn't stop there. He was kind of fascinated by how the computer had managed to beat him. The sort of tactics and gambits that the computer played that, to him, a chess grandmaster, these were kind of like new ways of playing the game. And when you think about chess, it's been around for a long time. You would think we would know all the ways to play it by now. But somehow, this computer had found something new about it. And this inspired Garry Kasparov to kind of start this new way of playing chess, where teams of humans and algorithms played against teams of humans and algorithms. He called it centaur chess. And because you have these like human-machine teammates. And what I love about this picture, I'm sorry it's a bit grainy, but that even in this kind of early days, without even any like voice interfaces or anything, they felt the need to kind of give their computer teammates a voice that has little stickers say beep, 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 beep all over it, which I quite enjoy. That sounds something like I would do. But, so let's jump forward a couple of decades to where we are now. We as a team of designers here in this doc, we work with data scientists and software engineers and business strategists, and we were really inspired by the approach that Kasparov took. How do we get this idea of centaur into like a system? How do I build a centaur system? This idea of human and teammate collaborating so effectively that they can change the way the game is played. The problem happens when you start thinking about how do you do that when you're a designer and you have to work with data scientists, software engineers, people who have a very different opinion about what good looks like and how a project should go. And so what we kind of found out is this, maybe not new to everyone, but this idea of like the language that you use is sort of the politic that you're working around. And unless you have a shared language, it's very hard to get a shared sense of what's valuable for a project and a shared sense of how you speak about the human in the context of the technology that you're building. And so if we wanted to kind of get this idea of human teammates working together, we need to stand in for the human in that process and articulate it as more of a teammate relationship and less like an algorithm dictating how you should do something. And so we started to kind of pair it back to the things that people can relate to more broadly. So we asked questions like, what do you expect from a human teammate? Our research came up with things like communication and expertise. We want our teammates to learn over time to get better at what they're doing. We want our teammates to be adaptable and efficient. And also this one, which is really interesting, which came out quite strongly, which was empathy. Like we want our teammates to sort of understand our context and being able to kind of figure out where we are emotionally. Now, if this is what we want from human teammates, we spend a lot of time working with our data scientist friends here to try and map those to something that we could create in a piece of software or a tool or a service. And that involved mapping these to a set of new language that we could use and became a common parlance around what these things actually mean. I'm going to go through what each of these are, so don't worry if you don't get this right away. So let's take this first one, observability. When you talk about communication, there's a principle of observability when you think about working with machines. So essentially, the machine needs to decide what is the relevant information that I need to give back to the user. Now, this is true of sort of all UX principles. Any UX designers in the room will be like, yeah, obviously. But when you're talking about AI systems, sometimes it's hard to find out what is the relevant information to kind of surface to the user. Actually, Netflix does this pretty well. So if you look at Netflix, you have a screen of images of movies you can watch, and there's quite a lot of detail that Netflix put in the background to calculate what kind of things to show you. But it doesn't show you all of that detail. It actually summarizes it quite efficiently to say, because you watched this, we're showing you these things. And even then, there's more granularity to say, with that prediction, we think that you'll like this 96%. We're 96% sure you're going to like this movie. And they're small things. So like in a service design parlance, you might call it evidencing, but it's about what to evidence and working with the data scientists to kind of boil up the important things. When you talk about expertise, you can talk about maybe directability. And what we say here is like, how do I get the system to understand what I want it to do? Even if it's just like a one-off thing. So think about your sort of sat navs. In early days, it used to be like, take me from A to B, and it would, but it wasn't very directable in the interim. If you wanted to change your course halfway through or respond to something that was new, you'd have to kind of reprogram the whole route. Now, companies like Google can sort of do this on the fly. They can switch you around, get a better route based on traffic, or they can avoid motorways or toll bridges. This sort of directability is something that where you can say, hey, I want you to do something, and I can go off and do that, has the expertise to take that into control. But directability isn't always explicit. So like when you talk about humans, sometimes I can kind of give direction with like a wink or a raised eyebrow or your tone of voice. These are sort of implicit directions. And when you think about how that maps into technology, you can think about something like Alexa, which actually kind of does this pretty well. So in this voice interface, if it asks you a question and you don't respond for a certain amount of time, it will take that as a direction and rephrase the question again in different words. And so this sort of is like unspoken directability. You can also think about it in terms of like the Apple Watch, where if you fall over, it looks like you had a hard fall, which it knows by the accelerometer in the watch, and you haven't moved afterwards. It takes that immobility as a direction and offers to call emergency services for you. And so when you think about directability, it's about thinking about all the ways in which you possibly could direct this system and the signals that mean something to you that you might kind of take for granted when you talk to a computer. This one is about feedback, and you could think about when you learn something, you like learn better over time. Feedback is exactly that, and actually the best example is probably something you're familiar with, is the Nest thermostat.
Third generation Nest learning thermostat. It has a bigger
All to make sounds.
and it's even better.
You don't really need to hear it, but you're probably familiar with this example.
Or down. It will catch on after a few days and create a personalized schedule for you. That's how the Nest thermostat saves energy.
So basically, if you didn't catch that, the Nest, as you do this very habitual thing that you're going to do anyway, turn your thermostat up and down, it learns that pattern and basically preempts it for you. What's interesting about this is the directability is built into a habit that you already have. So the user doesn't have to learn something new to program this technology. They're able to direct it by something that you would do naturally. And then when you think about adaptability, we kind of map that to resilience. So the resilience is basically the idea that the algorithm can cope with inconsistent input. And so what happens if the human just does something stupid or wrong? Or some circumstance changes? Does it just go crazy and throw all the toys out of the pram? Or does it manage that in a more kind of carefully considered way? One really good example is this machine here, which some of you might know already. This is called the Shaper Origin, and it's a CNC router. I'll play the video and then I'll talk about it in a second. I won't play the video because the video doesn't work.
Yep.
I'll try and explain. The Shaper Origin, you lay down these strips of tape and then you plonk this thing on your work surface, and it basically uses the tape to position itself in space, so it knows what you want to cut out of your piece of material, and basically you sorry, the video explains this way better.
They're on the right.
Simply apply shaper tape around the area to be cut and scan the surface to generate a map. Once you place your design, Origin knows what you want to cut and watches the workpiece to stay oriented to the plan. Precision motors continuously fine-tune the spindle's position as you follow your design, keeping cuts precise and on track. Origin remembers its position, so you can pause and restart your work. If you move too far off course, the blade automatically retracts, leaving you with a clean result.
So anyone who's into DIY just like drooling at the back. What's cool about this is there's two things. One is that humans are not good at cutting straight lines, and so this machine is able to account for that by kind of averaging out all your micro movements. But for the directability part of it, for the resilience part of it, is that when you try and cut something and you make a mistake, you try and cut something that's not in the plan, it just retracts the blade and makes sure you don't make that mistake by accident. And so what's interesting about this is like this robot actually has a lot of agency in that scene, so it's able to stop you doing something that it thinks is wrong. And that might be good for this scenario, but in other scenarios, like say like a chatbot, the human might be the part of that teammate who knows, who has the most information and knows when something is wrong and is best able to deal with it. And so you see in chatbots this emerging idea that when a chatbot fails to account for something, it's able to pass it off to a human who's better equipped to deal with the more emotional intelligence needed for this conversation. And then when you think about efficiency, you can think about responsiveness. Again, this is not one of these new things. Every UX designer in the house will be like, of course. And you can even look at the Nielsen-Norman guidelines on this, which are very helpful. So things like under a second, this feels like instantaneous. 1 second, you will notice a delay. 10 seconds, kind of sort of the limit of the user's attention. And above that, you kind of be wanting to show how long it's going to take. This is not new, but what is new is that oftentimes data science algorithms that run these AI applications are much more beefier than what we expect. And so when I'm trying to build something that kind of responds in a timely manner, I need to take these things into consideration even more so, because what might feel like a button will not feel like a button if it has to crunch a lot of big data in the background. But also what we've learned about this is that it's not necessarily about chasing the speed all the time. This example from Google, they built this visual search engine so you could take a picture of something and it would search the internet for that thing. That is great, but when they first started building it, they were so efficient with it. They chased every kind of like ounce of wait time out of it, and it was almost instantaneous, and users just couldn't get their head around it. They didn't understand why it had made a decision. It didn't understand that it was even searching for something. And so what they ended up doing was introducing this artificial lag. So this little wait time where you see it say searching is not necessary from a technology standpoint, but it is necessary from a usability standpoint, because it gives the user a chance to familiarize themselves with this new paradigm of searching for something. And then the last one, empathy, we've sort of mapped to contextuality. Like, what is the appropriate level of understanding so that you can figure out what context you're in and respond to it. So again, you could look at the Apple iPhone. They have a little bit of contextuality built in where if you enable it, it can detect when you're driving based on the accelerometer movement and tell you that automatically change into driving mode, where people who call you get a notification to say, hey, James is driving, and he'll leave a message and he'll pick you up after he's done. And this is a very good example of just understanding, like using algorithms, like AI algorithms, to understand the motion and understand your context and give you intelligent things to help you, be more human in that moment. Same with Duolingo. If anyone's ever tried to learn a language with Duolingo, you'll notice that your experience, the words that it tries to teach you, will be different from someone else's words because it learns from the things that you struggle with and the things that you get right and tries to cultivate your learning experience based on that. So there's a lot of things there. There's a lot of kind of new principles. We find that the best way to actually think about these principles is by acting them out. And so we actually get clients and on our project teams to come in and play the part. So in this scenario, this person is a smart camera, this person is a smart shelf, and this person is a person who just wants to buy a banana. And what's interesting is, like, when you actually sort of embody those experiences, you get a chance to know what it feels like to have your data used in this way. And I encourage people to kind of talk out loud about what this is doing, what's going on. And it always sounds silly at the start, but it's always the most kind of useful thing that we do with people. Maybe not the most useful, a useful thing we do with people. And so I'm going to finish with this quote from Kevin Kelly, is that sort of sums up the whole message here, is that it's not a race against the machines, it's not techno-positivism versus techno-fear. This is kind of a more collaborative approach. I do have recommended reading. Obviously the FJORD 2020 trends that you can get online, but also the FJORD 2019 trends, which you can get from the books in the corner. But also experiments with Google, Distill.pub, all these are kind of like experiments that you can get your hands on, just to start to learn what the limitations are of this technology and what it might mean for the services that you design. And then I also recommend this Elements of AI course from the University of Helsinki, which it's not necessarily super mathsy, but it does give you a good baseline that if you ever start working with data scientists, you at least have a little bit of their language that you can kind of latch hold of. And that's it. Thank you very much.